Hello friends, today we will understand the payload and sensors of Vikram lander, Chandrayaan 3 mission. India became the first country to land a spacecraft near the moon's south pole on the 23rd of August 2023, which is a technological triumph for the world's most populous nation. A lander with a rover inside touched down on the lunar surface at 6:04 p.m. on the 23rd of August 2023. Lander has 4 payloads on board, but before understanding payload, let's first understand what is payload. Payload is the scientific or technological instrument carried on board of a satellite for the specific purpose. Payload of lander are 1. Rambha with Langmuir probe, 2. Chased, 3. ILSA, 4. Laser retroreflector array. Today we will discuss detailed anatomy of Rambha payload. Rambha full form is Radio Anatomy of Moon-Bound Hypersensitive Ionosphere and Atmosphere, Rambha. Scientists have discovered that the moon has a very thin atmosphere compared to Earth. This atmosphere, also known as the moon's surface-bound exosphere, which contains a low-density plasma environment. During a total lunar eclipse, Rambha on the moon will observe presence of electrons that will confirm the plasma environment on the daytime of the moon is mainly composed of photoelectrons. The plasma environment around the moon varies depending on its exposure to the solar wind and the Earth's magnetic tail, or the Earth's plasma sheet. It has been suggested that the accumulation of plasma near the lunar surface is caused by the interaction between the solar wind and the moon's residual magnetic field. The recent discovery of a mini magnetosphere on the moon supports this idea. Measurements obtained from samples brought back by the Apollo missions indicated a photoelectron density of about 100 particles per cc near the lunar surface, with a characteristic length scale called the Debye length of 1 meter. The density of photoelectrons depends on the level of solar activity. The plasma environment near the lunar surface is influenced by the lunar surface potential, which ranges from 0 to 10 volts during lunar daytime. When photoelectrons are emitted from the lunar surface, it becomes positively charged. By studying different plasma parameters, scientists have estimated the lunar surface potential and the electric field at the surface. The electric field plays a role in the mobilization of lunar dust through electrostatic forces, causing positively charged dust particles to levitate. This adds an additional complexity to the near-surface plasma environment. The evolving solar conditions also affect the near-surface lunar plasma environment through various factors. The lunar ionosphere, which exists below an altitude of 30 km, has electron densities of around 100 particles per cc. The density reaches a peak of approximately 400 particles per cc at around 15 km altitude and gradually decreases at higher altitudes and toward the surface. Langmuir probes is a compact instruments traditionally used to measure electron density and temperature that have been employed to study plasma ionospheric environments. The proposed radio anatomy of moon-bound hypersensitive atmosphere and ionosphere Langmuir probe, Rambha LP, payload aims to obtain in-situ measurements of the lunar surface plasma during the Chandrayaan 3 mission. The primary objectives of the Rambha LP payload are to measure the ambient electron density and temperature near the lunar surface and study the temporal evolution of the lunar plasma density under varying solar conditions. The Langmuir probe, inserted into the plasma and electrically biased with respect to the spacecraft body, collects electron and ion currents. Its position relative to the photoelectron sheath depends on the electron density, solar elevation angle, and solar activity conditions. To ensure optimal performance, a 1-meter-long boom will separate the Rambha LP probe from the lander. The Rambha LP payload includes a mechanical system comprising a conductive spherical probe made of titanium alloy, a non-conductive 1-meter boom, a torsion spring-based deployment mechanism, and a hold and release system. The probe is stored on the top deck of the Chandrayaan 3 lander, protected from lunar dust. An onboard electronic system called the Rambha onboard controller controls the sensor voltage, data acquisition and spacecraft interface. It receives telecommands from the ground, acquires analog signals from the probe's front-end electronics, converts them into digital signals, and provides control signals to the probe. The collected data is packetized and transferred to the spacecraft's baseband data handling system. The Rambha LP probe has been designed, developed, and calibrated for measuring the plasma density of the lunar ionized environment surface. This payload will provide valuable in-situ measurements of the lunar near-surface plasma in unexplored regions of the Moon, particularly near the South Pole regions. These measurements will offer new insights into the characteristics of the lunar near-surface plasma environment. Thanks for watching.